There's more than one R. There's an R and there's another R. So what it's doing is it's duplicating the characters. So dupe allows you to dupe color and character at the same time. It'd be useful for games. My thinking along this line is the fact that if you're going to try to save variables, variables take up a lot of space. If you're using the memory already to move a sprite or to keep its definition, why not use that area of memory that's quicker and faster to move it around than trying to make up another table and keep a copy of it? Because the table in copy is slower than the actual source. Less program space, runs faster, faster access, takes up less time. As you can see, what this one right here is doing is the same thing I told you it was going to be doing. It's just changing the characters, swapping them out. See, like that one's changing. We can get out of this one too. This is the inverse command. It's going to invert bytes. Inverse inverses the bits from zeros to ones. So it's a machine language version. Let's just show you what it does. It's inverting all the bytes and all the characters at one time. You can inverse a single character or select a character or all of them. It's got some usefulness. And then here we have another program. What this one's going to do is do a swap color and reverse motion. I have a command here called reverse motion. Now what this does is it gives the illusion that these sprites are banking 90 degrees. It's actually swapping them when they crash. Here it comes. Oh, missed. One more pass. Come on. Making me crazy here. Oh God, this is taking forever. There we go. It didn't actually, it's the same sprite here. All it did was just swap the definition of the sprite and swap the color. But it gives the illusion that it banked 90 degrees. Now if one of these is invisible, it looks like it banked 90 degrees, but it didn't actually. You can use a actual line space to hit this. And it uses a thing called reverse motion. Reverse motion reverses the motion of a sprite. So this sprite is reversing motion. Anyways, we can get out of this too. This is one called get motion. Now, it occurred to me that if you want to be able to know the motion of a sprite, instead of trying to store all the motions of the sprite, if you randomly select them, look at how small this program is. I randomly select these numbers, and it stores it in the sprite itself. You can fetch them with this program called get motion. What it's useful for is knowing the direction and speed of a sprite. Now, it doesn't give you the location, but lots of times you don't need to know the location. You only need to know the direction and speed. And this is what it gives you, the direction and speed. Sprite number 24. Now I can do it much quicker than this because I'm only doing this, got a delay loop in here to show you that it's just checking a sprite and giving you the row and column velocities. That's extremely useful if you're doing, if you want to do a calculation, it's much quicker to do a calculation with these than it would be to do a whole bunch of numbers like I've seen programs written like that. Jump out of that program. Now we have one called get motion motion, where you take the two of them, combine the two of them, and see what you can do with it. I think this video is going to be a lot longer than I planned on, but bear with me. Okay, that's the last sprite up. Now what it's doing now is it's randomly selects a sprite and grabs the motion. What's really cool about this is if you run this program a long time and look at it, you will actually see some sprites actually do a curve on the screen and come back down because they're grabbing the motions of other sprites at the same time. And as they grab that motion, it actually gives them a trajectory that looks like they're actually doing circles. And it's not jumpy. It looks pretty cool because they're doing a very slight variation at a time. You see some of them reverse motion or swap motions. It's very useful for gaming. Here's our reverse motion command for it'll reverse a single sprite or all of them. I probably should have wrote one program that does all of these one at a time through the program. Would have been huge though. That way all the sprites would be up here and moving all the time. So the reverse motion, as you see, reverses all the sprites at the same time, so they all reverse. So it has some interesting game applications. It also reverses a single sprite, where you'll see a single sprite reverse a motion exactly where it's at. So this has some usefulness. We'll break out of this. This is going to use the move command to move from GROM to video. 760 bytes. It's going to move it onto the screen, because the screen is 768 bytes long. Then the next thing it's going to do is it's going to use a thing called a ripple. Now, a ripple means it's going to move from video, which is all the video memory. It starts at a 0 address and goes all the way up to 1. What it's going to do is it's going to read the address and then put it on screen. Now, what it's going to do is it's going to move that 32 characters at a time. So the ripple means that it moves the first character to the second character, then to the third character, then the fourth character. Now, there's already a sprite. There's already, a space there, so it's just going to be moving a single space like this, but it's going to do it in GPL across the entire screen. So this is the same thing as a call clear. This is the exact GPL command you'd use for a call clear. From video to video, 767 bytes, because the first one doesn't count because you already used it. From 0 address, to 1, the next one over, and do it 767 times. Then what we're going to do is we're going to do a VDP scan. We're going to scan all the VDP memory from 0 to this address, which is the top of VDP memory, 28 bytes at a time, and we're going to move that from video to video, 28 bytes, from the video address, which is this, V, to that screen address. Here we go. This is all the GPL memory in the computer. Gone. Now this is that across the screen that's doing that video write. Now, there are areas of VDP memory that aren't being used right now because I keep using new in the program. So whatever's in VDP memory you can look at. Now, RXB allows you to examine memory in VDP very easily this way. So you can see exactly what's going on. It's much quicker than call peaks and then convert them. Now, I have a command here called bias. Now, what bias does is if it reads off the screen, there's a bias of 96 added to all characters. You've probably heard about this in assembly. Now, we saved the program and we ran it. It didn't print out anything right now because I did something wrong in the program, but it does work. Probably should have rewrote that before I did the demo. This is call IO. This has been demoed like hundreds of thousands of times. It's actually the chimes routine. The difference is it's using the call IO in RXB. It talks to the input-output chip on the TI for the CRU addresses, and it talks to the IO chip. I don't remember the name of it right now. And what it did was it accessed the VDP memory to tell it to play that what I was loaded into the VDP memory. It does the same thing as assembling its routine, but it didn't use any assembly to do it. This is the execute routine. This is called execute. Now, execute is this right here, call execute 9838. Odd that that's the address, but that's where it ended up. What it's doing is it's executing that address. You can turn it into hex to see what it is. And the routine that it loaded is the video multiple byte read, video multiple byte write. The clearing of the screen is done by GPL. Now, I had a routine to do both of them in assembly, but here's the problem. It did it so fast it didn't look like anything was going on. Shows you how fast assembly is. Now, execute is not like Link. Link has a problem. Link is extremely slow in Extended Basic. It checks a lot of stuff. It pushes stuff out of the stack. It pops it off. It checks the stack. It's really slow. Execute is 5 times faster. This is my sector routine. This is reading the sectors off the... It works a classic amazingly. It's reading the sectors off the disk one at a time, and it's putting them on screen for you to look at. There's the B-load program, or B screen right there. Next one's going to be B screen save. Then it's going to be a character all. See, just like that. Anyways, we won't rotate through the entire disk because it's pretty big. So let's just break out of this with function 4. Now, lastly, this says create a user file from user. You can actually use user to create a user file to run a user file that calls a user file. Very confusing. Essentially what it is a DV80 file that can create another DV80 file to run that DV80 file from the original DV80 file. This is continuous. You can do this over and over again. And I used this program to write a program that wrote the DV80 file that I'm going to be using. This is the program it just wrote to create it out. I don't know of a lot of people that can do this, where they can actually make a program that writes a program that writes a program that runs the program it wrote. Confusing. Let's see what it does. Test user is a program right there that it wrote. Here it is. It's a one sector file. Let's run it. Here's a delay loop to show you that it is the last command. To end user, you have to have it the last command. If you're going to call another user file, it has to be the very last one. So call user, it ran the file, it's done. There it is, end of demo. Anyways, I wanted to show you what's coming out in RXB 2012. There are a lot more features that I've got that I haven't even showed you. A lot of routines too. But this will be the first of many demos I'm going to run for RXB, because I just decided that there needs to be demos for it. So anyway, guys, thanks for listening. Talk to you later.